Okay, let's talk about perpendicular lines. Slightly different. So we could say that lines that meet at right angles are perpendicular. So in other words, if one line is kind of crossing over another line and they're at 90 degrees to each other, then we could say that they are perpendicular lines. So I guess we could sum this up in a pretty simple little rule. We can prove that two equations, linear equations, are perpendicular to each other, wrong word, if the gradient of the two equations multiplied together to give us -1. Another way that this is sometimes written is it's written like this: m1 is equal to -1 over m2. But in all honesty, you can see why this one that I've just written in red works. Like if we got m1 by itself over on this side, we would need to divide both sides by m2, and that leaves us looking like this. So it doesn't matter if you remember just this, or if you do remember that it can be expressed like this, because you'd use this to work that out anyway. So let's have a look at an example of how we might use this. Okay, so we might be asked to show that the two equations are perpendicular to each other. Okay, so we have our two equations. We have y is equal to -3x minus 2 and y is equal to 1/3 x plus 4. First thing we need are our m1 value and our m2 value, our two gradients. So let's find them. So we can look and see that our gradient here is -3, and our gradient here is 1/3. So I can write them down. Very good. I can then substitute those values into that little formula that we had before, the equation that we had. And when I do that, I can see that -3 times -1/3 is actually -1. So it's true. Therefore, the two linear equations are perpendicular to each other. Okay, doc. Very good. We might use that perpendicular rule to help us work out another question, just as an example so you could see. So let's just say I needed to find an actual equation that is perpendicular to another equation. So this equation, 3y equals 12x minus 6. So I want to find a linear equation that is perpendicular to that, and it passes through the point -2, 8. Okay, so all right, well, let's write down that rule firstly. And you'll see that this rule is kind of interesting in that we don't have it in our general form. You remember, the general form is just y is equal to mx plus c. You'll note there's no coefficient on this y in our general rule. So we need to make sure that ours is fitting in with this general rule. It needs to be the same. So what can I do to make this look more like that? Well, I can just get y by itself. To do that, I'm going to divide all of the terms by 3. I can do that because I wrote it so that it would work. And when I do that, I'm going to end up with y is equal to 4x minus 2. Now, that is the exact same linear equation as this one here. It's just I've brought it down to a simpler form, into the general form. Okay, so we've got that sorted. What do we need to do now? Well, we're asked to be giving a linear equation for a perpendicular line. So we need to find the perpendicular gradient. That's what we really need to do. I know a little rule that will help me find out a perpendicular gradient. This is our m1 times m2 is equal to -1. So let me write down my two gradients. Well, I don't have two gradients. I only have a single gradient. I know that my gradient is 4 here. It's this other gradient that I'm looking for. So I'll write down what I do have. I'm going to write down that I know that 4 times my m2 should be equal to -1. I just need to get m2 by itself. So what can I do? I can divide both sides by 4, and I can find that my perpendicular gradient will be equal to -1/4. Wow, very good. I've got my perpendicular gradient. Now, knowing, of course, that it will be in this form here, I can rewrite this general equation that I've got highlighted there into the beginnings of a more specific rule for this particular equation I'm searching for. Okay, so let's move all this up a little bit so that we can see what we're doing. I'm going to rewrite my new equation. Now I've used a different colour to represent the fact that this is now the equation for the linear that is perpendicular, the linear equation that's perpendicular to my original one. Okay, so I now need to be able to find where my y-intercept is, what my c is. I did have a couple of, one single point, it had to pass through -2 and 8. So what I can do is I could say, well, when x is -2, y is equal to 8. I then substitute those values of x and y into my equation. I only have one unknown, which is c. I then manipulate both sides. I can, multiply that out. I can then take a half from both sides, and I end up with c is equal to 7.5. So I can then rewrite my beginnings of the perpendicular linear equation that I started with here, and I can actually put in my value for c. And I could say that y is equal to -1/4 x plus 7.5, and that is the linear equation that is perpendicular to my original, and it passes through that point of -2, 8. Okay.